Hello friends. I am Satish Lele. This video is part of my chemical process piping channel on YouTube. This video is about yard piping. Routing. Basically, yard piping is desirable to be assembled in one area on sleepers for economic efficiency, safety, ease of construction, operability, and maintenance and inspection, and to be planned in the shortest possible route by also preventing pipes from crossing each other. Following are the general notes with respect to the routing. Yard piping shall have its routing laid out along the oil dikes or roads as much as possible. An overall routing plan shall be made in consideration of spacing for electrical instrumentation ducts, trenches and firefighting piping, etc. Piping other than those connected to tanks shall not have its routing pass through the area surrounded by oil tank dikes. Routing shall be planned by keeping the road crossing areas as least as possible. Pump suction lines shall be routed to minimize pressure drop caused by piping configuration. Lines having process requirements for the gravity flow and slope of lines such as for flare, blow down, and condensate shall be planned at a higher priority. A minimum distance of half meter shall be secured from the guy or the fence to its support for the piping. Location. In order to set the location of the primary pipe support systems, the total plant layout must be established. This means that all the various disciplines must have a very good idea what equipment is required and its size. The plot plan must be reviewed by all the key people on the project and then approved by the client. Configuration. This is the selection of fit for purpose. Each main one, minor one and branch one must be looked at to determine its configuration. Will it be an overhead rack or a sleeper way? Will each be single deck player or multiple deck? Will the support be a single column or T support or multi-column support? How many columns? A second part of the configuration issue affects pipe racks in the process units themselves. This is the question of whether or not the pipe rack will support equipment such as air coolers, fan fans. Another part of configuration is the issue of intersections. Poor planning on this issue can cause problems later with the piping. Height. How high should each run of rack be? Should they be elevated or low sleepers? The sleepers are concrete with an embedded steel plate on the top. For sleepers, they need to be off the ground to allow for maintenance and drainage, also to prevent corrosion. For elevated multi-level racks, what should the separation be? For elevated racks, you must plan the height and the separation of the whole system together. The key element in the determination of separation is the line sizes to be carried on the racks. Width. This requires a detailed study of the total piping systems for the whole plant based on pipe rack routing. In the past, a study called the transposition was done to, as best you could, account for each line on each pipe rack. From this study, a birth sequence was established and the line spacing set. A percentage was added as an error factor and then the client's future reserve was added. This then constituted the minimum rack width. The final width would be set after all racks were sized and then some might be rounded up in width for consistency, based on the materials of construction and fabrication method. Spacing. This issue can be addressed after the transposition has been completed. The transposition identified all the ramp piping from the largest to the smallest. From this, the average line size for each leg of the ramp system can be established. With the pipe size information largest, smallest and average pipe size, the number and spacing of the pipe support vents can be set. The cost trade-off is evaluated and made between more pipe supports spaced closer together or fewer pipe supports and some sort of intermediate support system. Material of construction and fabrication method. What materials are the pipe racks to be made of and what will be the fabrication method? Pipe racks can be bare steel, steel with a concrete encasement or fireproofing, reinforced concrete or a combination. The steel can be steel structural shapes or pipe shape. The concrete fireproofing can be cast in place onto or around the steel columns and beams, or it can be precast onto the columns and beams prior to installation. The reinforced concrete pipe supports can also be cast in place or precast, then field erected. The space requirement for a reinforced concrete column or beam is about twice that of bare steel. Special lines. Sloping lines may be supported on the side of rack. Piping carrying caustic materials, chemicals, acids or similar services shall not be located near equipment or other piping with service temperatures exceeding 95 degrees centigrade and where avoidable should not be run over skilled routes. Piping smaller than 50 mm NB shall not be run in pipe racks or sleeperways. Where pipe sizes and racks require a support spacing which is less than the bent spacing, intermediate support beams shall be installed. Generally, small piping shall not be supported from larger piping. On sleeperways, sleepers shall be spaced to suit the pipe requiring the smallest support span, but should not be spaced less than 3,000 mm apart. Hot insulated lines should be grouped together and separated from cold lines. Support planning. Sleeper type, rack type or multi-level lines. Electrical and instrument cable tray. Sleeper type, durable, economically and easy to install. The precast concrete pipeline sleepers or supports are the answer to problems associated with metal, wood and cast-in-place concrete pipe sleepers. With the precast concrete pipeline sleeper there is no more corrosion or decay problems. Manufactured of high-strength steel reinforced concrete, the pipeline sleepers are resistant to salt and corrosive environments. With the precast pipeline sleepers, the product is delivered to the job site and can be set immediately when required. The cast-in-place sleepers, which require costly on-site construction, supervision, weather delays, and the task of getting ready-mix concrete to the most remote project sites. Offshore piping laid on sleepers that grade shall have minimum clearance of 400 mm between bottom of pipe and finished grade. Rack type for multi-level lines. Whenever possible, the tipper out shall be single-level. On single-level pipe racks, process piping shall be placed outside with utility and service piping on the middle. Where multi-level racks are required, generally process lines shall be placed on the lower rack levels, and utility and service piping shall be placed on the upper rack level. However, draining considerations shall be taken into account when placing process lines on multi-level racks by applying the following rules of thumb. If both ends of a process line are lower than the lower level, the line should be run in the lower level. Process lines that connect to nozzles elevated higher than the top level should be located in the top level. Process lines having one end lower than the lower level can run in either the lower or upper level. Specific elevations shall be established and maintained for lines running the north and south direction, and different elevations for lines running east and west. North and south and east and west pipe racks shall intersect midway between deck levels. At every change, the direction of the piping should change elevation, but care should be taken to minimize pocket. Electrical and instrument cable trays. These will normally be run in or off the side of the pit or else. Piping designer shall liaise with these disciplines to allocate these areas. Cable tray systems shall be kept away from hot lines. It shall be determined by considering the following items: width, spacing, elevation, and locations of supports for guide and stopper. Types of yard piping: process piping, drain oil, off-gas piping, utility piping, other. Electrical and instrumentation ducts shall be arranged at end of supports to allow easier check and maintenance. When horizontal loop is required in gravity flow piping such as flare, condensate lines, etc., such piping shall be arranged at end of supports. Road crossing. In general, equipment layout shall be prepared considering straight pipe rack. However, other shapes like LTU, HV, etc. can also be considered based on area available. The total width of pipe rack shall include 30% extra space or 1.5 m minimum for future modifications in units at later stage at all levels for tiers. The width of the rack shall be 6 meters, 8 meters, or 10 meters for single bay and 12 meters. 16 meters, or 20 meters, for double bay having 4 tiers maximum. For interconnecting pipes to different units, existing pipe racks to be expanded wherever possible considering foundation and column design. The spacing between pipe rack portals shall be taken as 6 meters in general. However, it can be changed to suit intra-unit distances. Each bay between 2 passing columns shall have secondary structural members at a span of 3 meters to enable supporting of small bore lines. Pipe racks shall be fireproofed, with provision of insert plates in supporting auxiliaries. Clearance beneath pipe rack shall be 4.5 meter minimum. Road clearance shall be 9 meter minimum for main road. Secondary road clearance shall be 5 meters. 20 mm diameter rod is provided above pipe rack to be made of CS. Corrosion wear pads shall be provided for all the lines at support location. Drain piping. Whenever possible, the main should be installed with a fall of not less than 1:101 meters fall for every 110 W to run in the direction of the steam flow. This flow will ensure that gravity, as well as the flow of steam, will assist in moving the condensate towards drain points where the condensate may be safely and effectively removed. The drain point must ensure that the condensate can reach the steam trap. Careful consideration must therefore be given to the design and location of drain points. Consideration must also be given to condensate remaining in steam main at shutdown, when steam flow ceases. Gravity will ensure that the water condensate will run along sloping pipework and collect at low pipes in the system. Steam traps should therefore be fitted to these low points. Next figure shows a 15 mm drain pipe connected directly to the bottom of the main. The amount of condensate formed in a large steam main under startup conditions is sufficient to require the provision of drain points at intervals of 30 meters to 50 meters, as well as natural low points such as at the bottom of riding pipe work. In normal operation, steam may flow along the main at speeds of up to 145 km per hour, dragging condensate along with it. Piping at sloped site. This is like drain piping on flat land. Unlike level lands, flow velocities and pressure can build up in systems on sloping land. This can pose substantial hazards to the system and to the land. Pipes with thermal expansion bellows. All pipes and vessels expand and contract in direct proportion to a temperature change. Whenever pipes are routed across structural movement joints in buildings, roads, bridges, etc., they will be subjected to displacements. Thanks for learning. If you like this video, please give a like to my channel and subscribe it.